Welcome to Continuous Delivery with Containers. I've called it the good, the bad, and the ugly. I'll let you decide what parts are good, bad, and ugly. So I'll introduce myself in a second, but the key pitch of today's talk really is container technology is pretty much everywhere. Serverless, you can argue, even more now, but this is focusing on container tech. And what we're kind of being pitched as container tech is becoming more mature is that everything is super rosy. Everything is super easy. Using the analogies of containers, we literally just, carve our applications up into these discrete chunks. We're calling them microservices. We put it in our containers, we ship it across the seas, and we are good to go. Yeah. Now, the challenge is, many of us have got tire fire type applications, yeah? Just nature of the game, legacy we call it, money-making code, sometimes I refer to it as. We've all got these challenges. How do we carve up our architecture, put it into containers? And if you've got a tire fire and you put it in a container, literally, you sometimes get tire fire in a container. Yeah, this is not a good look. It has spawned a whole new industry, though, called DevOps. You can see the firefighters here. This is pretty much how I make my money as a consultant, putting out fires with containers. So I think continuous delivery, though, is a catalyst for many things, and particularly with more modern technology, continuous delivery is even more important, I think, with the likes of containers, the likes of serverless. It's a massive topic, continuous delivery. I'm not going to focus on the business stuff today. I do like the business side of it, but sheer sort of, quantity you can get in a talk is always limited. I think PaaS, so platform as a service, and things like serverless are super interesting. It all depends on your context, yeah? Where your business is at, where your team skills are at, where your time frame's at, product market fit. There's so many things to consider that I'm not going to say containers are the way you should do things. You know your context better than I do. But if you are going all in on containers, hopefully for a good reason, this should give you a few hints today as to where not to do certain things and where to do other things as well. I'm going to be focusing more on the process and tooling stuff as opposed to live coding. I'm not very good at live coding, to be honest. I've got a free book on O'Reilly, Containerizing Continuous Delivery in Java. Is Java themed, obviously, but hopefully if you're programming in .NET or Ruby or Go, you can still get some value out of that one. And there's a full book coming, hopefully, later in the year. It's fantastic working on a book, but it's genuinely harder than I realized, yeah? Quite a challenge. So today, we've only got 45 minutes, so I've got to kind of distill the knowledge I want to share, and I've also got to pick really some areas to share. The first one is that the container image now becomes our single binary, the thing we need to push down the pipeline and test along the way. The anti-pattern I see people doing with this is they test their applications as usual, and the container is only a sort of deployment, an implementation detail, which can lead to some challenges. We need to add metadata. I think this is almost regardless of how you actually package and deploy your apps, you need to know what you've got running where. I'm sure many of you heard about Equifax over in the US. It even affected us here in the UK as well. Equifax, arguably they didn't even know what was running in certain areas. Some areas they did know and they chose to ignore them and they had a massive security breach. But many companies I initially consult to don't know what they've got running where. And containers provide a nice kind of thing we can label that container so we know if there's ever a security issue or whatever, we can go straight to that container, fix it, or build another one. We also, on that note, need to validate sort of system quality attributes. Some people call them non-functional or cross-functional requirements, but by now packaging our application within container technology, it does change the properties of the runtime. Just does change the fabric. As a Java developer, particularly a couple of years ago, that caught me out big time. Running stuff in containers behaves quite differently sometimes. So that's what I'm going to pick on today. This is me at Daniel Bryant UK on the Twitters, on LinkedIn, GitHub. You can pretty much find me anywhere there. My past, I started as an academic, did software development, DBA, CTO for a couple of small companies, and now I go to lots of conferences as part of my role as an independent tech consultant. I'm actually working with a Boston-based company over on the East Coast in the US at the moment. I'm based in the UK. I actually grew up just in Devon, so I know it's not popular in Cornwall to say you're from Devon, but I actually grew up in Devon. And now I'm very lucky I get to travel the world and learn from lots of interesting people at InfoQ, for example. And over the last 5 years, I worked with a company called Open Credo as well. Antonio, my ex-colleague in the front here, also did. And we worked on a bunch of projects with microservices, with Kubernetes, with Mesos, with Docker. And I learned a bunch of stuff there and on my own in the consultancy over the last couple of years as well. So I'm going to share, today is more focused on the technology, but we're all here at Agile on the Beach. We all know the people and the process is probably more important than the tech. Yeah, people and process more important than tech, but this is a tech-focused track, so it's going to be a tech-focused talk. How familiar are people with continuous delivery? Generally, people are sort of happy with continuous delivery. I'm seeing a few nods, hands, awesome. I'll just give a very quick overview in that case. It's fundamentally about producing valuable and robust software in short cycles. The key thing, and I've just come from Alan's talk, which is perfect for setting this up, the key thing is we're optimizing for feedback and learning. Optimizing for feedback and learning. We don't necessarily have to automatically deploy everything. We can do if we want, but continuous delivery says you should probably have something on a master branch that's tested, that's good to go at any given sort of time. So you can easily roll out security updates, things like that. Most of us, unless you're building, nuclear reactor software or some super, life-critical systems, velocity and stability is key to business success. If you're building, let's say, life-critical systems, maybe you don't need the velocity, for example. But many of us working in e-commerce places, a lot of companies I work with are e-commerce, and they want to go faster than their competitor. That gets them more customers, gets them more money. Steve, I think it was actually last year at this conference, Steve Smith said, fantastic quote, continuous delivery is achieved when stability and speed can satisfy business demand. I was like, boom, when I heard Steve say that, I was like, yes, Steve, that's what I've been thinking that for a while, but you said it in a really nice way. Steve is the same as me, we're both consultants. Discontinuous delivery occurs when you get the opposite. People want to go faster, or they're falling over, or they've got security issues, and they can't readily fix them. And the machinery around how they build and package software doesn't let them fix it as well. Hopefully not controversial. So creation of a build pipeline is mandatory for continuous delivery. You want to push some code change, some config change in one end. You want it to run the gauntlet of tests to prove it's worthy of production, of running, of adding value to your users. That pipeline is where the kind of magic happens. And this is a pretty much typical pipeline. It's slightly Java themed, because that's mainly where I code in these days. But I'm coding on my local laptop. I push my code typically to GitHub or Bitbucket, distributed version control. I might do some builds on Travis, Jenkins, Circle CI, that kind of thing. Might do some code quality checks, SonarQube, Code Climate, all that good stuff. Package my app, put it onto QA, do some kind of, maybe some manual testing even on QA. If it passes, I push it through to staging. And the difference between, say, QA and staging is staging may be more realistic. The sort of further we go in this direction, the more realistic the testing gets. QA, I may be mocking and stubbing. Staging, I may be using sandbox environments. I may be integrating, say, with PayPal or with Stripe, and not using real money, but using their sandbox, their play version of their API, for example. Ultimately, we push through into production. Yeah, it might be a manual thing, might be an automated thing. I don't mind about that too much. All these graphics, if they are a little bit small, they're in the book, they're on the website, so you can check them out. A lot of companies I initially consult with think this is pretty much continuous delivery. And it is, but the missing part is the feedback bit, getting that loop going so we can go super fast, yeah? We want to run a bunch of hypotheses. We want to say, we think this is how we're going to make more money. Did it work? Yes or no, yeah? We want to also continually improve the ops side of things, continually improve the developer experience, continually improve the architecture. And without this loop, we don't get that. Continuous delivery ends when your service or application is retired, yeah? Not when it's deployed. Continuous delivery, the loop ends when you retire a service. Now, the impact of containers on continuous delivery. So, again, are people generally familiar with Docker and containers and so forth? Two nods. It's fundamentally operating system level virtualization. People in the Java space like me, we're very used to dealing with the JVM, the Java virtual machine, which is like a sort of runtime OS. Many of us are used to dealing with VMs or cloud, which is kind of like a hardware virtualization. And containers are somewhere in the middle, operating system level virtualization. You share a kernel. So that's if you crash the kernel, you crash all the containers that are sharing the kernel. But fundamentally, it's a real lightweight form of virtualization. Yeah, it revolves around C groups, control groups, which specify resources on the container and the thing running within them. You can namespace the network, the processes, so they don't interact and clash with each other. And you've got a root file system, which if you trash it, don't trash your actual file system. It's a great way, and Docker basically revolutionized technology. You know, Docker didn't create containers, but they put a very nice developer experience on top of working with things like LXC. They've moved on, they don't use LXC anymore, they've moved on to other things. But fundamentally, there's a bunch of technologies. I'm mainly going to talk about Docker because I use that one the most, but there's Rocket, there's LXD, there's Windows containers. That, you know, take your pick, there's many different technologies. Most of the things I'm going to talk about today are agnostic to those. The thing I want you to take away from this bit of the talk is that the container image becomes what we call the single binary. Yeah, in the Java world, we used to package jars or wars or ears, .NET and NuGet packages, that kind of thing. That used to be our single binary that we pushed down the pipeline and tested. We did some load testing on that. We did some security testing on that. Now, we're deploying into a container. The container package, the container image, needs to become the thing we run all of our tests on. Now, you can argue, like unit tests and code integration tests, you can run them outside the container. I'll talk about that in a minute. I don't mind about that. But any kind of sort of functional tests or non-functional tests that are business-facing, I think should be run on the container, on the packaged version of the app. This was our pipeline. How does it alter with containers? And I've used Docker as the kind of symbol here, but any kind of container tech. Fundamentally, I think 4 places it has changed for me as a developer, as a tester, as an operator. First one is on my local machine, I probably now need to have some kind of container packaging system, Docker, to do some kind of happy path tests when I'm coding. I might do my coding very fast in an IDE, but at some point I want to run my happy path tests on the single binary. I also now am not building necessarily just a language-specific artifact, I'm building a container image as well. Therefore, the way I spin up and test probably changes. And of course, the way I deploy changes. You don't really want to be running containers just, you know, with systemd or with some kind of init system. You're probably going to be loading in more buzzwords. You're going to be bringing in Kubernetes, you're bringing in Mesos, Amazon ECS, Nomad. Take your pick, as many different competing technologies, but fundamentally these technologies schedule and orchestrate the containers. There's many more different things going on now. We as humans, not very good at that kind of stuff. We use machines to actually orchestrate and schedule. A little quick aside that microservices do multiply the challenges. I'm not going to talk about microservices too much today. I've got another talk about that. But you've probably got multiple pipelines now. And you might want to fan in on one staging environment, or you might want to be doing some kind of, you know, contract-based testing or message-based sort of verification between the things. So bear in mind, if you're running microservices, you're going to be having multiples of these pipelines, and you do need some mechanism to coordinate what you're delivering is good. Shameless plug, did a talk on the virtual Java user group, I think about a year ago or so now, a bit less. You can check that one out for more info on my thoughts around my mistakes as well, around the testing with microservices. Creating a pipeline for containers. So let's look at the developer experience. So one of the key things, again, you know, it doesn't really matter what kind of tech or language you're using, you want to make your development environment as production-like as possible. Now, this is getting harder and harder as production environments are becoming more elastic, you know, with cloud and so forth, and really powerful. Like, you know, I started my career like on an Amstrad CPC 464, and you know, back when I was 10 years old, 64K of RAM. But the kind of stuff I can spin up on the cloud now is just insane from my perspective. So we can't always make our local environment like production, but we try as best we can. I often do a lot of coding locally, but then I'll copy the artifact or the code into a container and test locally. So I've got Docker on this machine. I code my Java apps in my usual dev cycle, but then I package it in Docker and do testing before I push my code up to GitHub, say. I definitely think you need to do at least the happy path tests locally. Like I say, you want to minimize the friction as a developer. You don't want to be constantly spinning up containers and things, but you do want to know or have an idea of how your app's going to be running in production. And your app now is going to be running in containers. Just as a brief example of this, I'm not sure I'll have time to talk about it later, but the Java JVM, the kind of virtual machine that runs my Java apps, pre-Java, I think it was 9, so like a couple of years ago now, it was not control group aware. So when I spun up a Java app in a container, it looked to the host to get the information that it used to base all its config files. So one project I worked on, we were using massive Amazon AWS cloud. There are 32 cores, crazy amounts of RAM. And we were spinning up like 32 containers and pinning them to a CPU each. And the OS Docker constrained the apps to run on one CPU. It's very good at that. Constrained the apps to run within the memory, but the JVM thought it had 32 cores. Thought it had like crazy amounts of RAM. And it bases the fork join pool, and it bases the way it garbage collects, and it bases a bunch of things which completely make sense. 20 years ago, when the JVM was created, you only ran one JVM on your machine. So it naturally hoovered up all the resources to make the application run as best it could. Now, as in, I've had apps that kind of lock up because they think they've got 32 cores to do garbage collection, and they actually haven't. Yeah, they don't sort of they don't actually get access to more than you allow them. The control groups, the C groups, and Docker work very well, but they will not perform as expected. So just heads up on that one. You also want to use identical base images. So you're bringing in an operating system into your artifact. Previously, you just packaged a Python app or a Ruby app or whatever. Now you're packaging an OS because you're going to share the kernel. Yeah. Now you're bringing in more things, so the security attack surface goes up, and a whole bunch of other little nuances between different versions of, say, Linux. You'd like to think the distros in Linux are the same, but they're not. Trust me on this one. And we had one example where the team was deploying into production using CentOS, and it was hardened using AppArmor, and it was SE Linux, and all this kind of good stuff. But the team when I rolled in, were testing on Ubuntu locally, without AppArmor, without SE Linux, that kind of stuff. And it was massively different. We developed locally and pushed to production. They obviously, somewhere along the build pipeline, they rebuilt the image using the CentOS base, and it just completely, behaved differently. So the key thing, or actually it's on another slide, I want to mention to you, is do coordinate with your ops team, your platform team, InfoSec. Me as a developer, I've had to get more operationally aware. Not everyone has to, but someone on the team pretty much has to, because there's operational impact that affects me as a developer and when I'm working as a developer. Just a little quick aside, this is more around how to spin up things locally. So I blogged about this on the Open Credo blog a while ago. If you're working locally in a microservice system, you often got lots of services that are dependent, or you're dependent on them. Your service is dependent on lots of different other services. You can, I've talked about this in the blog, you can use things like mocks, stubs, service virtualization. I worked on a tool called Hoverfly, open source service virtualization tool, which is quite nice. But because compute is so cheap now, we actually started spinning up on-demand mini production environments. And each developer had their own version of it. It was Mesos in this case, or Kubernetes, take your pick. But they had their own version of a production environment with sort of simulated services, things like that. And QAs could also spin up their own environment, deploy the services they wanted to, and run their tests. So I think we called it environment leasing, or production in a box is another one. You can't often run these things locally. When your system gets to a certain size, when you've got 10, 100, whatever, microservices, even with a powerful Mac, you can't run everything locally. So this notion of being able to, on demand, spin up a production-like environment is quite powerful. And I'm seeing this more and more. Azure have just released dev spaces. I think it was yesterday, it went GA, and they are offering in Azure the ability to spin up these little isolated dev environments, so every developer can have their own little mini production. Yeah. Again, not saying that's the way necessarily to go, but it's an interesting option. There's always trade-offs with these things. I'm actually working on a tool called Telepresence, open source tool with Kubernetes, with DataWire. It's actually a CNCF, it's a Cloud Native Computing Foundation, like an open source foundation, now owns the Telepresence code, so it's completely free and open source. Telepresence is effectively a two-way proxy between your local machine and a Kubernetes cluster. So we're working with a bunch of clients who are running quite big microservice systems, but we're developing locally one service with all my familiar IDE and debug tooling locally, and my Mac is behaving as if it was in the cluster. So we're doing an on-demand spin-up of a cluster, we're proxying in using telepresence, it's super simple to do it, and then we're developing locally and debugging locally and so forth. So there's a couple of other tools that do very similar. The very interesting pattern if you are working with containers locally, there are tools out there now to minimize the friction if you can't spin up everything locally. And that's just, telepresence works. Dialing back for a second, one thing I learned as a developer is that the Docker file content is super important. And the Docker file is basically a manifest of how we're now building our artifact. What we're shipping ultimately to production is a language binary or a language package with an OS and with some config. And the Docker file is the way that we specify that using Docker. OS choice is super important. That from brings in, I think it's maybe Debian, Jesse, it brings in an OS, and I need to know that as a developer. I need to know what OS I'm developing on. Config, you can see I'm exposing ports there and doing various things. I need to think about that kind of stuff now. I've worked with a couple of teams, I clearly won't mention them, but they were running full-fat Ubuntu with loads of ports open, everything available for debug, and it was just a hacker's dream, basically. Yeah, everything was fully open. So I was like, well, get crumbs, lock down the OS, lock down the ports. You've got to be really careful about what you expose in configuration. And I've done some daft stuff as well. I'm not going to lie on that one. You're putting your build artifact in there, you're exposing ports. When you're doing Java, you have to choose all these. Do I run the JDK, the JRE? There's a lot of basically things we need to think about. Statically compiled binaries, or do we want to bring in more shared libraries? If you're a Python developer, you're used to using virtualenv. Do you need to now, because the container kind of operates as a virtualenv? There's all these questions that we as developers were suddenly flooded with when we started coding with Docker, we're deploying with Docker. And this was my takeaway. Yeah. Talk to the sysadmin people. Talk to the platform team. Their operational knowledge is invaluable. Yeah? And one of the things I do now as a consultant, if I go in and I'm lucky enough to be brought in early, because often as a consultant you're brought in when stuff's going wrong, but if I'm brought in early enough, one of my first questions are, have you chatted to ops? Have you chatted to InfoSec? And if you haven't, that's one of the first things we do. Because not only do they need to, on a human level, feel involved, but at a business level, their knowledge is super valuable. But even from a technical level, there's multiple levels here. I've seen several projects fail because they didn't engage with the InfoSec team. And right at the last minute, InfoSec spotted what was going on and locked everything down, and it canned the project. So everyone has got a distinct value in the organization. Bring their input in. Really key. One ugly pattern I see is people using different test and prod containers. So they're packaging like a full-fat kind of container with all their test tools in it, and then when they ship to production, they strip it right down. But the problem with this, and that's chucking all that stuff in there, the problem with this is you see configuration drift. What you're testing in this dev test container often subtly different than what you're pushing into production. I've done it. It's human nature. You forget to update something in the two different manifests. Oh, no. I recommend using what's called sidecars instead. You hear a lot about sidecars now with service meshes and all this kind of stuff, but a sidecar is effectively something that runs alongside your other app. So what we often do, there's a very interesting blog post that goes into more. It's not mine, Alexi, fantastic blog post. It goes into more detail around building your production app as it will always be deployed into production. So whatever choices you're making in terms of it being in production, that's what you build pretty much straight away. But you build a container image that contains all your test tools, maybe your pre-canned data. You've got maybe a MySQL in there or H2 database, in-memory database. And then with Docker or Kubernetes, you can link the two when you're testing. And you can drive all the testing from the sidecar, and you're not polluting your production container. Yeah? That's a nice pattern I picked up along the way. It's kind of similar. Docker, not many people know about this, actually. You do multi-stage builds. And you can actually notice, if you're familiar with Docker, that something that looks kind of weird is there's two froms in this. Typically, you only have one from. But it allows you to have, and this is a Go example. In Go, you need more stuff to build your app and your container. Running it, you can get away with a super lightweight container. Yeah, but I've used this kind of to also in Java and Python, we put some more tests and so forth in here. It kind of goes against my single binary thing because we are actually building two binaries. But by having all the data, in the same file, it minimizes the chance of configuration drift. So this is a nice pattern to explore as well if you're wanting to run many things in your kind of build stage before you actually package the final artifact. Moving on a little bit, so I'm not going to cover lots about actually how you build containers, because it's kind of language specific, it's kind of specific on your build tool. My report, my free O'Reilly report, just talks about Jenkins, because that's the one I use the most, but I'll let you have a look at that one. What I am going to pick on is metadata. Again, many companies I work with, one of my sort of like classic, crafty consultant moments is I go, can you tell me exactly what versions of all the OS you're running in production? Can you tell me what versions of the Java logging library you're running in production? And a random number, but 99 out of 100 don't know. They can't tell me. They go, oh, we can find out. We can look through all our code manifests. We can go into GitHub. We can have a look. And even then, they often struggle. And when they do struggle, they discover an absolute nightmare. Got multiple versions of logging frameworks, multiple versions of OSs. You need to have this metadata available, and it needs to be reviewed regularly. You need to know what kind of stuff is actually running in production. So you need to know like the version of the code you got. A lot of these modern technologies, like containers, like serverless as well, allow us as engineers to go faster. And this is great, but going faster without knowing sort of where you're going or where you've got to is very dangerous. Yeah, when you're looking for product market fit, it's amazing. But when you're running a mission critical business, you really need to be a bit more careful about what, and I've been there, yeah, about what we're actually running in production, and we need to know. So we need to add this kind of stuff like build metadata. We need to also probably ascribe to each container. Has it been QA'd? Have we definitely built the container? Has someone not tried to do an injection attack into and built the container and pushed it to our repo? Do we have various security profiles running on the container? How do we get access to these things? Now, a lot of my stuff comes from a gent called Gareth Rushgrove, a fantastic gent. I always enjoy chatting to him, based near Cambridge. He runs the DevOps Weekly newsletter. So if you haven't signed up for DevOps Weekly, please do. Gareth is an amazing kind of resource, and he's taught me a bunch about this stuff. One of the first things with metadata I would say is you often version containers, or you should version containers. Don't use what's called the latest tag in Docker. It's the semantics of it are wonky, and I actually got tripped over this in a project we worked on about 3 years ago now, where we were building these latest containers, and latest meant different things depending on whether you were on CI versus local machines and things. There's a blog post there that goes into more detail by Matt, fantastic blog post. I would recommend always using semantic versioning, semver, major, minor, patch. And you'll notice, someone pointed out when I did this presentation a couple of weeks ago, in my later examples, I don't do this, so shame on me. But that's, I don't know, it's me being lazy, I guess. But when we're actually working with clients, we always try to do semantic versioning in terms of what we're actually building and deploying. How do you add this metadata onto containers or into images? Docker has something called labels. It's kind of, we're all familiar with it, like using the good old interwebs URL syntax. You can put labels on. You can ascribe them to your Docker file, do labels. So you can say, Daniel built this using this OS, that kind of stuff. It's pretty basic. Often, there's an example. Often you want to be automating some of this. So micro-scaling solutions, they're actually gone out of business now, but they did some fantastic work around creating a make file to auto-generate Docker labels. And there was even some guidelines. They were trying to create like a label schema to give guidelines for us as engineers how to use metadata most appropriately in our Docker containers. So some additional resources for you there. You can add labels at runtime. So you could do some, say, testing and say, yeah, it's now QA passed, and add that label. But you have to Docker commit to get that label to be saved, to be persisted in the container. And by Docker committing, you're creating a new image, a new layer, which kind of validates my single binary idea. So at the moment, that's kind of a non-starter for metadata, to be honest. Metadata post-build can't use this. There is some discussion that maybe in the future. What I've ended up doing is using external registries with metadata support. So JFrog, Nexus, you often have to pay to get the, they have OSS versions, but you often have to pay to get the API controls so that you can build an artifact, you can add metadata to it, and you can update the metadata as your image flows down through the pipeline. Now, I am obliged to say this is a family-friendly audience. The frog is merely hugging the whale here. This is some slightly duff marketing on the JFrog team, but the JFrog actual tooling is really quite cool, yeah. I use that at Nexus quite a lot. I'm going to just very quickly mention about 2 new technologies from Google called Grapheus and Critis. This is the only part of the presentation where I haven't actually used this stuff in production yet. So I'm exploring it with a few clients and so forth. It's looking very interesting as a way to add metadata. And they're trying to cover metadata for vulnerabilities, for packaging, for a whole bunch of stuff. And Shopify really are leading the way. If you want to learn how to run Kubernetes and containers at scale, go to Shopify's blog, it's fantastic. But they've teamed up, they were a beta tester for Google around this stuff. And you'll recognize the kind of pipeline at the top here. And they're sort of building container images and deploying onto Kubernetes. This happens to be GKE, Google's hosted Kubernetes engine over here. But what they're doing, as they're building their image, kind of like my pipeline, along the way, they're adding metadata to this Grapheus. And it's a metadata repository with certain guarantees. And you can also cryptographically sign the data. So you know the data, it can't be altered and so forth. So pushing stuff along the pipeline, what you also do, is you cannot, there's some config in GKE that says you cannot deploy a container unless it meets these requirements. And you can basically say, unless it's been signed in these ways, so signed that it's been built by us, signed that it's been QA'd, signed that it's been security verified, the GKE will not physically run the container. It will give you an error back, which is quite nice. And because it does that by actually looking at in the Grapheus repo, you can do these things called attestations. So when you build the container, you effectively cryptographically sign the container. You can run some QA, cryptographically sign, the attestation, and then you say, when I'm deploying it, we must have these attestations on the container we're deploying. Again, I'm only experimenting with this. I think it's super interesting, and I think with Shopify and a lot of others looking at it, I might move towards some of this stuff as well. Looking more on the QA front, just a brief kind of thing here. A lot of people ask me, how do I spin up containers to test, or how do I do load tests? What I often do is just use things like Docker Compose or a Kubernetes script. A lot of the language-specific testing frameworks now have support for spinning up Docker containers. So some fantastic, in the Java world, fantastic Maven plugins that spin up a Docker container. You can run some JUnit tests on it. All the other kind of languages I work with, Go, JavaScript, have the same stuff now. And when I'm sort of running maybe an integration test on a subset of the whole system, I just use very similar to what we're actually doing in production. However we define in production that these apps can talk to each other, we often use a kind of subset of that to spin these things up. I've got another talk that goes more into that if you do want some more details. But I really like to verify things like these in terms of system quality attributes. You want to be ensuring that your architecture is not devolving. Worked on a couple of projects where we started off with good intentions building new microservices from old monoliths, but the microservices, we followed similar habits, became mini monoliths. Yeah? So you want to always keep an idea on architecture. Kind of agnostic to containers, but do run checks on architecture. You want to be doing performance and load testing. Like I mentioned earlier on, containers do have an impact on the runtime, so you want to catch these things early. And I'm going to pick on today security testing. I see this problems with this the most at the moment, in that because we're bringing in more abstractions, I've got my Java app, I'm putting it in Docker, I'm running it on Kubernetes, I'm running it on Amazon VMs, crazy level of abstractions. Yeah, typical computer thing, one more abstraction solves our problems. And often it does, it makes it easier for us to work with as developers, but every layer introduces new security challenges. Yeah. So I'm going to pick on those a little bit today. Oh, there's a couple of links there to follow up on that. That one in particular, Aaron Gratafiore, it's a 2-year-old talk now, but it's a fantastic talk. Aaron is like one of the leading minds in container security. He's got some fantastic reports you can download. They're super geeky. They go into real stuff that's kind of beyond me, but I really enjoyed chatting to Aaron, and I really enjoyed reading his stuff. So if you're like an ops person, a platform person, you get a lot of value out of reading Aaron's work around container security. And so I'm hoping most of you, this is a Java example, but I'm hoping most of you do code scanning, static vulnerability scanning. It's super cheap to do. I had this example in my book. This is a duff bit of code that tries to run, it's almost like a SQL injection attack. And I put a simple couple of lines in my build config in Java, and it produces a risk report, and it says you've got 3 critical security errors. You're not closing buffers properly, you're exposing SQL injection attacks. This kind of stuff, regardless of language, is very easy to do. Always make sure your code is scanned. The stuff that you are writing, we are writing, adding a lot of value to our business, make sure you're scanning that stuff. Next level up, things like containers and serverless allow us to spin things up very fast and go very fast. But we often rely on other people's work. We stand on the shoulders of giants. But we bring in dependencies like they're free candy, like they're free sweets, yeah? So we need to make sure, and OWASP is an open consortium that talks about security. I'm hoping many of you have heard of OWASP. Please do go to their website. They've got a bunch of security guidelines, a bunch of great tools, talks about things like threat modeling, fantastic stuff. One of their tools is the dependency scanner. It's Java, .NET, Python, and Ruby, I think. There's a bunch of different languages it supports. In the Java world, I bring in this kind of 10 lines of config, and what it does is it looks at the dependencies I've brought in, phones out to the National Vulnerability Database in the US and says, are any of these dependencies you're running here, do they have known CVEs, known common vulnerabilities and exploits? And if they do, it reports back and says, yes, these things are vulnerable. Often you do a search and a new version of your dependency is out and you upgrade. If there's not a new version, you have to make the call. Are you happy running that CVE in production? What was this? It's an old Spring Boot app. It's like a 6-month-old Spring Boot app I ran this on it, and it found 5 CVEs from like 6 months where I deployed it and it was fine. There's now been 5 vulnerabilities found. So bumped the versions of the libraries and redeployed it, and it was all good. Containers actually make it very easy. Once you find stuff, you can repackage, push it down the pipeline, redeploy. But you've got to know about this stuff up front. And there's some real nice GUIs as well to show to project managers and so forth. You can say, look, we're running a risk. By pushing this into production now, we might be legally liable. People are going to jail. Developers are going to jail. Like in the Volkswagen scandal, one of the developers went to jail for what he did. And increasingly, I think with Equifax and other things, there's going to be more regulation coming on our industry. So we definitely, we're kind of self-selecting by coming to a conference. We're keen to learn. We're keen to be the vanguard. So we should be saying to all our teams, all our communities here in Cornwall, Devon, the rest of the UK, we should be saying this stuff we cannot no longer ignore. Even if you do this kind of stuff and report up to management and they ultimately report it, I think you're still being a professional by saying we've got to be aware of some of this stuff. And it does extend to containers. So static scanning, you're bringing in a whole OS now. You're vulnerable to Heartbleed and you're vulnerable to all these kind of OS level attacks. And many developers, myself included a few years ago, are not familiar with those risks. Yeah. So you need to statically scan the image you've built. And the best way to do this is through a static scanner. There's an open source one called Claire. There's commercial variants, Aqua, a couple of other ones I've used as well. A lot like Docker Hub includes a scanner in their commercial offerings. But this open source Claire package, a very nice gent called Armin, saw me do this talk a while ago, and actually said, I've now packaged up this Claire application into a Docker container. So you can spin it up and point it at other Docker containers, and it will scan them for known vulnerabilities. Fantastic. So massive hat tip to Armin there, open source in action. He's run through all the kind of how you set it up and how you spin it up. And what I did as an example, it's just some code there, is this was in, I think, November time, I did a Docker pull on the latest version of the Java OpenJDK runtime. She said, Docker pull, millions of developers are probably doing this, millions. And then I did a scan. I had my Claire scanner already built. I did a scan, and this was the number of CVEs that came up. If you can't see, this is one CVE, that's one CVE, that's one CVE. That's crazy amounts of CVEs. In my operating system, there were known vulnerabilities and exploits. And some of them have been known for years, and the attack vector is so tiny. But again, we still need to know this stuff, even if we're not, we're going to be inaccurate, we're going to take inaction by not doing anything about it. We still need to know about this stuff. We are taking a risk. We're bringing in a new convenient tool, containers, but they bring in some risks for us as developers. So we need to think about these things. Yeah, we need to really think about security in our industry. This is classic. You'll totally get this. I've done this at a few other conferences, and people are not familiar with the last responsible moment. But in the Agile world, this for us is a no-brainer. Yeah, when it comes to business functionality, I start a project, I don't know very much, so I delay my decision until the last responsible moment. I've learned so much from watching Dan North stand on the stage and talk about this stuff. You learn as much as you can. If you don't make a decision here, one is going to be made for you. So the last responsible moment, we have as much knowledge as possible. We make a decision and we go with it. And people often push back to me and say, with things like security in particular and scalability, they say, let's wait till the last responsible moment. Yeah. And the news flash is sometimes the last responsible moment is up front. I'll say it again, yeah. The newsflash with non-functional, with system quality attributes, sometimes the last responsible moment is like day 0. It's up front. I don't think necessarily modern platforms and architectures make this easier. There's more components. I'm sure you've heard several buzzwords today. There's more things we've got to learn as developers. What I have seen a few times, and I'm sure I've contributed to, is it leads to a bit of broken windows. You know, I can fix it. I can fix this right, or I can fix it fast. Show me what fast looks like. Yeah. And I've seen a few of these in IT projects, and I'm working really hard to not contribute to this kind of stuff. To really, at the start, bang the drum. We need to know what kind of scalability is required for this app. We need to know how secure this app should be. How many times have you tried to do a user story and someone will say to you, like, how secure should it be? And they go, yeah, security. Yeah, security. We want security. No, how secure should it be? Yeah, I want security. What does that mean? As in, it's always a trade-off, and we need to have these awkward discussions up front. And you can even codify it, and there's a fantastic BDD-like framework. I can't remember what it's called now, but find me out if you want to know. There's a BDD framework that wraps the OWASP Z attack proxy. It's an automated pen testing tool. And we can write BDD-like instructions, given when then, that run security checks, pen tests on applications. So these things, the tools are out there. We need to make sure that they're used. Whistle stop tour, because I've only got like 3 minutes now, I think. Important things not covered. So I hinted earlier, be aware, if you're bringing in containers, it alters the compute fabric. Yeah, this is my example where I got burned on the C group, the JVM not being C group aware. Setting memory I got burned at, the container will kill, or out of memory kill applications if you get the memory config wrong. I did that one a few times as well. Entropy was a random one. So we were having applications locking up in production. And we didn't know why. And we ultimately managed to recreate the problem locally. And when we were running a stack trace in Java, we saw the applications always froze when we were doing a crypto operation, a login, a session token generation thing. And that puzzled us quite a bit. But then we realized that in production, we were running all these containers on one massive Amazon instance. The entropy, the source of randomness for crypto operations was being rapidly exhausted because there's no keyboard input. There's no people mashing a mouse, which a lot of machines use those kind of things to generate the pool of entropy that then creates the randomness, the pseudo-randomness. So one fix we found is you can move to instead of dev random on the Linux operating system or Mac operating system, dev random blocks if there's no entropy. Yeah, so our applications were just hanging. Instead, you can use urandom, which is pseudo-random. There may be security ramifications. Most people think not now, but it's a conscious choice. In Java, you have to explicitly override the JVM to use dev urandom if you're doing a lot of container-based crypto operations. Deployment, this is a whole topic in itself. There's a bunch of tools that are popping up now that aim to make the developer experience much nicer. Some of them are even hiding Docker. There's something called GitCube, where it gives you a Heroku or Cloud Foundry-like experience where you're just interacting with Git, and all the building of containers and stuff is going on in the cluster. So there's a lot of things here. This is a fantastic blog by Shahid, and it's a long blog, but it's seriously worth reading if it's Kubernetes specific, I think, yeah. But if you're looking to build a tool set, a developer experience locally, please do read this. There's just some examples of whether you want to build locally or in the cluster. Final thing, observability is core. I haven't talked about it too much due to time constraints, but you need to put your hooks, metrics, and so forth, metrics, logging, tracing, into your apps, and you need to make sure the container propagates them correctly. I had one classic example where people were writing logs to containers. The containers were actually blowing up in production, and we were losing our logs. It was like the perfect crime, yeah? You had no evidence. It was kind of a nightmare. So we made sure we logged off the container onto the host, and we swept it on using Logstash. But just think about these things. Finally, appreciate there's a lot of stuff coming at you, and I do talk a bit fast sometimes as well, but containers are not a silver bullet, one of the key takeaways. If you're going to go all in, a lot of people think, and are being sold by vendors sometimes, this is the solution. I actually like this picture, yeah. I think, just test the water. It's not that expensive to spin some stuff up, play with it. Don't spend months or years building this perfect system. Like Alan's talk said this just a minute ago. Just deliver fast and often. Deliver fast and just build that learning machine, build that iterations. Obvious one, but containers don't get rid of the need for good architectural practices. I have seen this pattern a little bit. We crammed this monolith into a container and called it a microservice. Yeah, it's a classic one. I've also seen we put an API on top of the monolith and called it a microservice as well. But just think about these things. All this fantastic tech is there. It can actually make our jobs as engineers even harder. Yeah, so we need to be a bit conscious of this stuff. Hopefully bang on time. And the summary message really is continuous delivery, I think, is even more important as we're getting more powerful tooling to work with. Modern architectures, event-driven systems, microservices, serverless technologies, I think make this more important. We need to codify our learnings and codify what we believe is acceptable into the pipeline. This job is too difficult for any one person or team now. We have to codify this stuff into the pipeline. It can then be audited, it can be run really fast. This is key. Container images must be the single source of truth. They're not an implementation detail. Please don't build a pipeline and package it into a container at the end. It's definitely an anti-pattern. Add metadata so you know what is deployed where, and you can very easily spot when a vulnerability does pop up. You can go straight there, rebuild all those containers, and fix the issue. Something called mechanical sympathy. Apologies, I didn't actually put it in this talk, but this is from a previous talk. But mechanical sympathy is all about understanding, having sympathy or empathy with the technology. Understand how containers impact your runtime, how they impact security, how they impact performance, these kind of things. And not all developers, I certainly wasn't 5 years ago, were not operationally aware. So you need to work and make sure everyone's kind of comfortable with this stuff. Technology is becoming stable, mature. When I worked on my first container project in 2013 or so, it was crazy gluing things together, stuff falling over, things blowing up in the corner. Now the technology is pretty stable, but we still need to reapply the CD practices with these tools. That is really key. All the good practices with CD, reapply them. I shall say at that moment, thank you very much.